there, back again. So we are going to do another rate problem because it seems like the AP people like rate problems. And this one, I like this one. It's from the 2019, so it's as current as you can get. So 2019, there you go, 2019, AB Calculus AB. Okay, and this one is graphing calculator again, but and you guys won't have a calculator question as far as I know. So, but the concepts are still the same. So here we go. This is the rate in, rate out problem. Fish enter a lake at a rate modeled by the function e, and e of t is 20 plus 15 sine pi over 6t. Fish leave the lake at a rate, oh, there you go, at a rate modeled by the function L. L of t is equal to 4 plus 2 to the 0.1 t squared. Okay, both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. T equals 0. Okay, and then they ask us, how many fish enter the lake over the 5-hour period? Okay, this is very typical for the AP style rate problems. So they give us a rate and they want to know how many fish. So if you're given a rate and you want to know how much, absolutely you're going to anti-derive. And we're going to anti-derive from what we know, which is at t equals 0 to t equals 5. Okay, so 0 to 5. So here we go. 0 to 5, E of t, because they want to know how many fish enter the lake over that period. And here we go. We're going to enter that into our calculator here. So, clear y. So, y1 is equal to 20 plus 15 sine. And do make sure that you are in radians. Confirm that, and then we'll do pi, second function, pi x over 6, and then we'll put parentheses around that, and then check it again, make sure it's exactly how it looks, and it looks good. Okay, and now we've got that into our calculator. We can exit that, and now remember how to do the integral is math 9. And that's 0 to 5. And we can do section function. No, not second function, you guys. Alpha F4 gives us the Y1. Sorry. And there we go. So we get 100. And then we can't have a portion of a fish. So then they say, give your answer to the nearest whole number. So we're going to say that's 153. And we're talking fish. Fish. Okay, so that's A. Now B. Here we go. Let's just move up. What is the average number of fish that leave the lake per hour over this 5-hour period? Now, this will not be on your guys' AP test because they said average value is not on the test. But had it been, remember this would be our lave or lav or whatever, however we want to say, is 1 over 5 minus 0, 0 to 5, L of t dt. So I'm not going to bother calculating that because we don't need it, but that's how you would have done average value, which you remember because we did study it. Okay, at what time t for 0 to 8 is the largest number of fish in the lake, or the greatest, is the greatest number of fish in the lake? Okay, so hopefully if you're thinking greatest number, you're thinking maximum value, right? And what kind of maximum is this if they're giving us the bounds? You're absolutely right. Absolute max, right? Absolute max. So if you get an absolute max, you still start out the same. You're going to find your critical value, right, by taking the derivative, setting it equal to 0. Okay, so we want the greatest number of fish. So I'm going to let f of t equal number of fish in the lake. So f prime of t is how the rate of the fish changing in the lake, right? Rate of change of fish, which is kind of weird, but there you have it, right? So remember, the rate of change is going to be the rate in minus, you got it, rate in minus rate out. Okay, now the rate in, they told us was, you got it, E of t, and the rate out is L of t. All right, now we've got an expression for the derivative, right? So we have the derivative. We're going to set that equal to, absolutely, for critical values, we take the derivative and set it equal to 0. So now we're looking when does E of t equal, L of t, right? That'll be our critical value. So I'm going to go back to my calculator, and I've got E of t in here already, and I'm going to put in L of t. So my y2 is going to be 4 plus 2 to the 0.1 x squared. That looks right to me. Okay, and enter that. And we know it's going to be from 0 to 8, so we can plug in our window from 0 to 3. And then let's go ahead and look at it. 0 to 3. Why did I do 0 to 3? I meant 0 to 8. Oh, for goodness sakes. All right, let's go back to our window and change that. 8. Sorry about that. This is hard for me, hard for the old woman to do calculator problems. Technology. Oh dear. Okay, so I think it's going up here and up here. So I'm going to go ahead and change my window. And we're going to have like 100 and, I don't know what we're going to have, but we should go up. We're not going to have negative fish, right? Negative rate. So we'll do 0 to, let's do 50 and see what happens. Let's see if we get our intersection there. That's looking much better. Look at that. And it looks like it's going to happen around, around 6. So let's do second function. Second function calc, intersect, enter, 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 and see what we get. Okay, so our intersection here is at 6.2. So t is equal to 6.2035. 2035. And we can just truncate that number. Okay. And I'm going to go back and look. So my y1 was that really thick line. So you can see, if we go back to the graph, my in is greater than my out all the way up until 6.025. So if we're looking and we want to do a quick sign chart, is this going to be a max or a min? We can look at it. Okay, do we have to do a sign chart? No, you don't. So this is positive here because E of t is greater than L of t, and then it goes negative. So this is a relative max. Is it the absolute max, though? We still don't know, do we? So we do need to make the table. So I'm going to do time 0. Can you see that? Yeah, you can. Great. Okay, and then f of t. Okay, so at 0, okay, 0, 6.2035, and then at 8. Okay, so at 0, do they give us a starting point? No, they don't. Well, if we anti-derive and we're going from 0 to 0, I think we're going to have 0, aren't we? Or they don't tell us what we're starting with, do they? Oh, that's a weird one. Well, I'm going to choose this as my absolute max then, because if we anti-derive, we'd go would go from 0 to 0, which is going to equal 0. We antiderive this from 0 to 6.235 of f prime of t. So if we do that calculation on here, we're going to do math 9. Oops, quit. Math 9, sorry about that. We're going to go 0, 6.2035, and that's going to be my y1, right? This is my y1 minus my y2. So we're going to do, oh shoot, I did the wrong thing. Quit. Go back. Sorry. It's teaching the old dog new tricks again. Alpha F1, there we go, minus alpha F4, sorry. So I just did my rate in minus my rate out. So that's what I'm doing here. And we do X, and there we go. So 135.01. And then we're going to go from 0 to 8. Now it should be less, right? Because we looked at the picture, and this is our maximum, and then we're decreasing. So it should be less, but we're going to check it and prove it to the grader, right? That's grading this, that we know that we checked our bounds. And sure enough, it is 80.91. So we have to justify our answer. So, and I can use f of t, or you can write out the number of fish in the lake has absolute max at t is equal to 6.2035 because f at 6.2035 is equal to 135 fish. Okay. And that's not it. We've got one more. The fun just doesn't end here. Yay. Okay, let's go. Here we go. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. Okay, so the rate of change increasing or decreasing. Now that's kind of an interesting question. Let's think about that. So we would take the second derivative because the rate of change, so to find the rate of change is increasing. So to find if something is increasing or decreasing, we would take the derivative, right, and look at the sign. So here we're doing the rate of change in the number of fish. So we want to know if that's increasing or decreasing at 5 a.m. Okay, so let's do f double prime at 5 would equal e prime at 5 minus L prime at 5. Okay, can we do that? I think we can. So we can do e prime at 5 would be the derivative, which is math 8. And again, we're going to do our y1 and stick in 5. So I got a negative 6.8017. And we're going to find L prime of 5. We're going to do the same thing, math 8, x, and then alpha f4, y2, and 5. And 3.9210. Okay, so we can say f double prime of 5 is equal to negative 6.8017 minus 3.9210, which is a negative, right? So we're gonna take that and subtract it. We might as well do the calculation since we have the calculator. 7227. So f double prime at 5 is less than 0. So therefore f prime at 5 is decreasing. And that's it. We've done it.